In this video, we will learn about topic 7, permutation and combinations. Okay, so first we will focus for 7.1, permutations. Alright, so these are the learning outcomes for 7.1. We will learn different technique for permutation involving multiplication technique, and then permutation for different object, and then permutation for identical object. Okay, let's get started. So, what is actually permutation? A permutation of a set of objects in any arrangement of definite order. Means susunan sangat penting for permutation. Basically, we want to arrange something. We want to arrange a letter, an object, or any numbers. Okay. Alright. So basically, when it comes to permutation without repetition, we will use the notation of NPN if number of arrangement is same as number of object that we want to arrange. Okay, so NPN can be simplified as n factorial. So this is for a permutation without repetition case. If permutation for repetition case, we will use n to the power of n. You don't have to remember this, just understand the situation, then you will know how to solve the problem. So let's get started with the problem. Okay, so the first question, how many 3-digit number can be made from the integers 2, 3, and 4? So here in this case, we have to arrange 3-digit number. Means in this case, our n is 3. Okay, so our calculation should be out of 3-digit, we want to arrange all of it. So 3p3, and this can be simplified as 3 factorial. You may start compute this in your calculator, or if you want to calculate this manually, 3 factorial has the same meaning as 3 times 2 times 1. Here our answer would be 6. Okay, so either you straight away compute 3p3, or you may compute as 3 factorial, or if using multiplication technique, this is the same as 3 times 2 times 1. Okay, so that's next one. We have 3 different people, Aisyah, Badrul, and Daniel, must be scheduled for a job interview. In how many different order can this be done? So our keyword here is different orders. Means arrangement once again is important. Since we have 3 different people, so our n is 3. Means our calculation should be 3p3. Or same as before, we can simplify this as 3 factorial, or using multiplication technique, this is 3 times 2 times 1. So 6. Okay. Next example. So in how many ways can 10 instructor, so our n in this case is 10, be assigned to 10 section of a course in maths? Okay, our keyword here is assign. Means we want to arrange people. Arrangement is important. That's why we solve this by using permutation technique. Since n is 10, so our calculation should be 10p10, or can be simplified as 10 factorial. Or if you want to use multiplication technique, it's a little bit long. It's 10 times 9 times 8, and the list goes on up to 1. So simplify this up, our answer would be 362 8800. Please compute together with me. Make sure you can find the factorial button or the NPR button in your calculator. Okay. Kalau kes yang macam ni, better kita guna button NPR lah, ataupun kita guna button factorial, rather than awak nak kira 1, 10, darab 9, darab 8, panjang sampai 1. Membazir masa. Lagi cepat kalau guna factorial ataupun NPR. Okay, so moving on, next one. So how many 4-digit number can be formed? So n in this case is 4, and then keyword is form. So if we want to form a digit, means arrangement is important. So once again, we have to use permutation in this case. Okay, we have two different situations now. For the first one, repetition are allowed. Sorry, no repetition are allowed. Means we can only use each digit once. Okay, so for this case, if repetition is not allowed, out of four options, okay, we will arrange all of it. So for P4, or you can rewrite this as 4 factorial. In this case, our answer would be 24. Alright, that's for the first one. Repetition not allowed. Straight away, one go for P4. Okay, moving on to the second situation when repetition is allowed. Okay, our n is still 4. So let's do a box here to represent the situation. We want to rearrange this 4 digit, but each number can be used more than one time. Semua nombor tu kita boleh guna banyak kali. For example, kalau semua saya nak guna 5, maksudnya 5, 5, 5, 5. It's allowed in this case. Okay. So, if this happen, we have to consider each digit. Semua tempat, semua kotak tu kita kena consider case by case. What I meant here is, okay, we go to the first box. Okay, for this first digit, we have 4 options. So, out of 4 options, we want to arrange, that's why I use P, at this first digit place. So, for P1 here. And then the same thing would happen on the second box because we still have 4 options. Okay, sebab nombor tu boleh pakai banyak kali. So, we have to times with 4P1. And then the same thing would happen for the last 2 remaining digit. So we have 4P1 times with 4P1. And this can be simplified as 4P1 to the power of 4. Alright, so 4 to the power of 4, our answer would be 256. Okay, so be careful with the situation of the question, whether repetition is allowed or repetition is not allowed. If repetition not allowed, then at one go, you just use 4P4 or 4 factorial. But if repetition is allowed, then you have to consider digit by digit. You have to consider each box. Kalau saya lukis kotak tu kan, blank-blank tu maksudnya kotak, kena consider setiap kotak. Alright. Okay, that's for the digit. Moving on. So, let's move on to the next part, permutation for different number of object. All this while kita ada, let's say n is 5, all 5 things we want to rearrange. But what happen if number of object and number of option that we have would be different? Apa yang saya maksudkan kat sini, contohnya, let's say saya ada 5 barang, tapi saya nak susun 4 barang je. Okay, apa akan jadi? Alright, so that's why we have a notation of NPR. Sebab tu dalam calculator dia guna button NPR lah. We can use that if we have same number of option and object or different number of option and object. Okay, so that's for different number. Notation berubah but then still the same process. Okay, let's go through the example. So suppose we have 4 different flags. How many different signal could you make by using 2 flags for the first situation? Second situation is 2 flags or 3 flags. Okay, so our option now is 4. That's the first main thing. You have to identify value for n. And in this case is 4. Okay, and then what's the keyword that we know? Arrangement is important. We have make different signal. So, kita nak buat signal yang berbeza, automatically arrangement is important in this case. Okay, let's go through to the first example, first situation. Our R here is 2. We only want to make a signal by using 2 flags. So, altogether we have 4 options. So, 4P2. Out of 4 options, we only want to arrange 2 options of the flag. So, 4P2. In this case, our answer is 12. Okay, how about the second situation? We have 2 different cases. We have R equal to 2 using 2 flags or R equal to 3. Now, we have 2 separate situations. So, for R equal to 2, our calculation is still the same, 4P2. Or means we have another situation, so we have to add this up. Kena guna tambah kat sini or sebab dia melibatkan situasi yang berbeza, case yang berbeza. So another case is when we use R as 3. 3 flag kat situ. So 4P3. In this case, our final answer would be 36. Okay. But if the question use the word and, means this case is overlap. Saya tambahlah. Kalau dalam soalan tu guna R is 2 and R is 3. So we can either use 2 ataupun kita guna 3 dalam masa yang sama. So our calculation would be 4P2 times with 4P3. So careful with the keyword of or ataupun and. Kalau or senang cerita tambah. Kalau and senang cerita kena darab. Okay. So next example. We have a relay team that has 5 members. Okay, that's the first main thing. Our N now would be 5. How many way can a coach arrange? That's the key word. So we know we will use permutation process. 4 of them. So R in this case is 4. So straight away our calculation will be out of 5 people, they will arrange 4 of them. So 5P4. In this case, answer should be 120. I hope you can find the button in your calculator. Tak ada masalah nak cari NPR button. Okay, 5P4 is 120. Okay, next one. Okay, how many arrangement? Once again, arrangement. So we have permutation here of the letter word begin. Are there if? Okay, so from the word begin now, we have 5 different letters. So N in this case would be 5. Okay, for the first case, 3 letters are used. Means now R would be 3. So our calculation straight away would be 5P3. So 5P3 is 60. Okay. Moving on to the second situation. 4 letters are used, but now repetition is allowed. Means each letter can be used more than once. Setiap huruf boleh guna banyak kali. Okay, careful here. If this happen, we have to consider each box. Kotak by kotak kita tak boleh terus buat calculation 5P4. Kalau kita buat 5P4, itu untuk repetition not allowed. Kita boleh pakai satu huruf sekali je. But then now, repetition allowed, setiap huruf boleh pakai banyak kali. So, kita kena consider setiap tempat tu. Okay, start with the first box. We have 5 options that can be arranged in the first box. So, 5P1. Okay, moving on to the second place. Still the same thing. We still have 5 different options. Sebab huruf yang kita dah pakai tadi, kita boleh guna lagi sekali. So, times with 5P1. And then, same thing happen for the last 2. So, kita ada 5P1 times with 5P1. So, here, this is actually 5 to the power of 4. Alright, so our answer would be 625. Okay, nampak beza So, careful with the word repetition is allowed. Okay, kalau repetition allowed, then kita kena consider setiap tempat. Kalau repetition not allowed, then straight away awak boleh terus buat 5P4. Okay, and then next situation, all of the letter are used. Kat sini dia tak bagi tahu repetition allowed, then we assume repetition not allowed. Saya tulislah kat sini, repetition not allowed. Biasanya kalau dia tak mention in the question, maksudnya tak boleh lah tu, not allowed Okay, R is 5 in this case. So, our calculation straight away, 5P5. Since N and R are same, so we can simplify this as 5 factorial. So, our answer should be 120. Alright, settle with that one. Moving on. Alright, so kita up level sikit. Now, we have to solve permutation with a condition. Ada certain syarat dalam soalan tu, macam mana kita nak susun. Okay, example 10. Find the number of arrangement of 4 digit Okay, arrangement. So it's permutation. 4 digit. That is our N from the taken set 1, 2, 3, and 4. Okay, how many way can the number be arranged so that for the first case, number begin with digit 1. Okay, and in this case is 4. Let's start with the first situation. We have to arrange 4 digit number. So I have 4 blank here. And then it must begin with digit 1. So for the first box, kita mesti guna nombor 1. Alright, so from the list just now, we only have one option for number 1. Saya highlight colour biru, ada satu je pilihan nombor 1. And then that number must be used on the first box. Kotak pertama mesti letak nombor 1 tu. So calculation now should be 1P1. Satu je pilihan nombor 1 mesti susun kat kotak yang pertama. That's why 1P1. Okay, times with now. Yang tinggal ada berapa pilihan? We have digit 2, 3 or 4. Means we have 3 different options that we can arrange on the last 3. Remaining 3 space. Ada 3 lagi pilihan that kita boleh susun kat 3 tempat berbeza belakang tu. So straight away we can use 3P3. Nampak beza? Tadi first mesti guna kat kotak pertama, that's why 1P1. Ada 3 lagi nombor yang kita boleh susun kat 3 tempat belakang tu, that's why I use 3P3. So this can be simplified as 1 times 3 factorial. So our answer here is 6. Okay. Moving on for the second situation, the number do not begin with digit 1. Okay, still the same situation. We have to arrange 4 digit number, but now cannot begin with 1. So kalau tak nak mula dengan 1, we have 3 different option here. We can use either number 2, number 3 or number 4. Ada 3 pilihan. So calculation for the first box will be 3P1. Out of 3 option, we want to arrange on the first box, 3P1. Okay, times with, alright. So now, if one number, we don't know, either 2, 3 or 4, one number we already use on the first box, okay, satu nombor dah guna, remaining would be another 3 option. Ada 3 lagi nombor kita belum guna that we will rearrange in remaining 3 space left. Lagi 3 kotak yang tinggal tu ada 3 nombor kita boleh guna. So our arrangement would be 3P3. Simplify this up, we have 3 times with 3 factorial. So our answer would be 18. Okay. So, ingat baca soalan hati-hati, consider tempat mana yang ada syarat. So, kita akan start arrange with tempat yang bersyarat. Carefully read the question, consider the condition for each space. We will begin the permutation process for that space first. Okay. Kita pergi cuba lagi, next question. So, example 11. Alright, now we have 4 sisters and 2 brothers. So altogether now we would have 6 different people. 4 sisters and 2 brothers. Okay, arrange in a different way in a straight line for several photographs. Okay, highlight the keyword here is arrange. So we know this is permutation process. How many different arrangement possible if for the first case there are no restriction? Tak ada syarat, tak ada apa-apa condition kat sini. Okay, if that happen, we can straight away arrange them. So R in this case is still 6 because we want to arrange all of them. So our calculation would be 6P6, or you can simplify as 6 factorial. So here our answer should be 720. Okay, settle. Quite easy. Kalau no restriction tu maksudnya terus kira lah macam biasa . Kita pergi yang situasi kedua. Okay. The 2 brother must be separated. 2 orang brother ni dia asyik gaduh. So kita mesti dudukkan dia asing-asing. Okay. For separated case, first step number 1 always begin with non-condition situation. Maksudnya yang ada syarat siapa? Brother yang ada syarat. Girls tak ada syarat kan? Sister tadi. So kita start arrange the sister first. Okay, altogether we have 4 sister. So saya susun ada 4 tempat yang sister boleh duduk. Saya namakanlah sister 1, sister 2, sister 3, sister number 4. Okay, so if we have 4 different sister, we can rearrange them between this place. So our calculation would be 4p4. Or you can use 4 factorial, the same thing. Okay. Alright, so ada 4 sister, saya boleh rearrange. Now, to ensure those two brother must be separated, kita nak pastikan brother ni duduk asing, we must put them in between this sister. Kalau nak pastikan two brother ni duduk asing-asing, kita letak dia antara sister. Itu cara dia kan? Okay, so now we can count together how many spaces do we have between the sister. Saya buat arrow 1, 2, 3, 4, 5. Okay, tempat saya buat arrow tu maksudnya brother boleh duduk kat situ. Kalau saya guna tempat tu, for sure, the brother must be separated. Okay, altogether we have 5 different empty space for the brother, but we only want to arrange 2 of them. So, 5p2. Sebab ada 2 brother lah. Kalau ada, let's say, 3 brother, awak buatlah 5p3. Kira tempat yang ada, susun brother yang ada. So, 5p2 dah Alright. So, this would be equal to 480. Okay. So, itu cara kita nak kira untuk case separated. Okay. Saya tambahlah soalan. Soalan ni dah biasanya dia package dah tu tau. The two brother must be separated. Saya tambah soalan C. The two brothers must be together. Tadi dia duduk asing-asing. Sekarang dia mesti duduk bersama-sama. Dia mesti duduk side by side. Okay. So, if this happen, kita akan assume dia ikat sebagai satu tempat. Kita anggap dia bersama-sama. Nak alih seorang lagi akan ikut. Dia macam ibarat kembar yang kita ikat bersama. Okay. So, tadi kita buat dulu space. Altogether, we have 6 different brother and sister kan. Yang ada 6 tempat. Okay. 2 brother must be together. Okay. Saya letak je kat mana-mana kotak. Tapi mesti side by side. Let's say lah saya letak kat sini. Itu tempat untuk brother number 1. And then this tempat untuk brother number 2. Saya ikat dia sebagai satu kotak. Sebab kita assume dia mesti duduk bersama-sama. Okay. And then the remaining 4 space would be for the remaining sister lah. Kita ada sister 1, sister 2, sister 3 and sister number 4. Okay. And between the sisters and these two brother, we can rearrange them. Maksudnya saya boleh tukar susunan antara sister dengan brother. Tapi brother ni mesti kira sebagai 2 orang. Okay, so how many space we have? We have number 1, 2. The 2 brothers saya anggap sebagai satu arrangement. So 3, 4 and 5. Means our arrangement would be 5p5. Kita dah boleh tukar-tukar susunan antara sister and brother. But then brother we assume together. Okay, tak cukup lagi. Why? Because now saya baru kira brother 1, brother 2. Kita boleh tukar juga susunan between those 2 brother. Sebab dia tak cakap siapa mesti duduk kiri, siapa mesti duduk kanan. Kita boleh tukar between the 2 of them. So, we have to multiply with 2p2. Kalau ada 3 brother, 3p3. Macam tu. Alright, so 5p5 can be simplified as 5 factorial. Okay, 2p2 can be simplified as 2 factorial. Berapa jawapan dia? Awak kira lah. Sebab saya baru tambah soalan ni. Saya tak kira jawapan dia berapa. Tapi itulah jalan kerja dia. 5 factorial times with 2 factorial. Itu untuk together. These 2 types is quite famous situation lah. Separated case dengan together. Okay, so for separated case, awak kira tempat. Ingat ada berapa space yang boleh letak. Awak letak orang tu. Kalau together case, kita ikat sebagai satu case and then kita susun. Okay, nanti dah banyak-banyak exercise. Awak dah nampak lah pattern macam ni. Okay, kita go to the next example. Alright, so arrange 6 boys and 3 girls. Okay, altogether now we have 9 different people. 6 of them are boys and then remaining 3 would be the girls in a straight line so that the girls are separated. Okay, that is the condition. We have to arrange. Means this is permutation process. The girls must be separated. Okay. So remember our step just now. First, we begin with the people with no condition. Siapa yang tak ada syarat tadi? Boys yang tak ada syarat. So kita mula dengan boys. Altogether we have 6 boys. Saya buat 6 kotak. 3, 4, 5, 6. Saya label lah. We have boy 1, boy 2, boy 3, 5, and 6. Okay. And between these two boys, we can rearrange them without the condition. Kita boleh susun je tanpa apa-apa syarat. So, our calculation should be 6P6. Ataupun awak nak guna 6 factorial. Boleh, tak ada masalah. Okay, now we want to arrange the girls. Remember the condition? Girls must be separated. Means we can arrange them in between the boys. Kita boleh susun girl ni di antara lelaki-lelaki yang dah ada. Okay, so let's count together. How many space do we have? Okay, arrow saya buat 1, 2, 3, 4, 5, 6, 7. Means now all together I would have 7 empty space, but then I only want to arrange 3 girls there. So 7P3. Alright, in this case our answer should be 151, 200. Okay, simple kan? So kalau dah faham case, okay, nampak separated je, ingat cara ni. Mula dulu susun yang tak ada syarat. Because boy tak kisah, saya susun dulu boy 6P6. And then kira ada berapa space in between the boys. Ada 7 space. But then we only want to arrange 3 of the girls. So 7P3. Okay. Itu teknik dia lah untuk case separated. It's valid for all condition. Tak semestinya orang. Kalau nak guna untuk susun nombor boleh. Nak guna untuk susun huruf pun boleh. Sama je cara dia. Okay. Kita pergi next one. Okay. There are 10 students. Okay. Out of whom 6 are female. Now our N is 10. Out of 10, 6 are female means remaining 4 would be male student. How many possible arrangements? So this is permutation condition. If they are arranged in a row. So arranged in a row means no condition at all, no restriction at all. We have to arrange all of them. So R in this case is 10. So calculation should be 10P10 or 10 factorial. You know the drill already. Okay, settle. Ni kira lah dapat berapa panjang jawapan tu. Okay. Yang penting calculation kita 10 factorial. Kejap saya tekan. Oh ni 36 28800. Okay. So that's for part A. Part B, male always sits on one side and female on the other side. Dia nak duduk bergrouping lah tu. Macam awak dalam kelas lah kan. Satu side lelaki duduk, satu side perempuan duduk. Awak tak duduk sebelah-sebelah kan. Selalunya lah. Okay. So kita imagine itu situation dia. Altogether we have 10. Okay, saya buat 10 space dulu. 1, 2, 3, 4. Okay, 4 tu ada 4 different male. Okay, saya labelkan M1, M2, M3, M4. Okay. So, ini dia mesti nak duduk bersama-sama dalam satu side. Okay. And then we have remaining another 6 female. So, kita ada F1, F2, F3, F4, 5 and 6. Okay. Yang girls ni pun dia satu grouping lah. Girl punya group. Dia duduk bersama-sama juga. Okay. So, let's start the arrangement. Means even though the boys sit together, 4 of them, we didn't have a condition between the boys, between the male student. Maksudnya M1 dengan M2 nak tukar tempat boleh, tak ada masalah. M2, M3 nak tukar kan. Kita boleh rearrange all the male student. Our calculation should be out of 4, arrange 4 of them. So 4P4. Okay, settle for the males. Now, moving on to the female student, same thing happen here. Between the female, we can still rearrange them. Kita boleh tukar-tukar susunan ni antara female dengan female ni lah. Okay, so our calculation now should be 6P6. Okay, and then last one, we have to consider these two group. Because condition we only mention male and female on the other side. Maksudnya satu side male, satu lagi side female. Dia tak cakap siapa duduk kiri, siapa duduk kanan. Maksudnya between these two group, I still can rearrange dia. Kita terbalikkan dia lah. Mula dengan female, lepas tu male pula. Okay, so what happened here? We have to multiply with 2P2. Since we have 2 different group. Let's say lah kalau kita ada 3 different group. Okay, maksudnya kita kena times with 3P3. Itu syarat dia. So, yang depan ni saya rearrange for male. Saya buat tu. Yang kedua saya rearrange between the female. Okay. Yang ketiga, saya rearrange between the two group. Okay, kena faham setiap satu tu awak susun siapa sebenarnya. If you don't want to use permutation P button, you can simplify this using factorial because N and R are the same. So, this is equal to 4 factorial times 6 factorial times 2 factorial. Okay, so our answer in this case would be 34560. Okay, settle. That's for example 13. Okay, moving on, example 15. So, in how many ways can 4 girl and 5 boys sit in a row if the boy and girl must sit alternate to each other? Okay, tadi nak duduk satu side kan? Sekarang nak duduk selang-seli pula. Okay, so kalau duduk selang-seli, kita kena check dulu number of people that we want to arrange. Now we have girls and boys. If they have the same number, awak boleh mula dengan sesiapa pun kalau bilangan dia sama banyak. If they have different number, so kita start dengan siapa yang lagi ramai. Okay, so now between girl and boy, boy lagi ramai. So we must begin with boy. Alright, so since dia dah tulis kotak kat situ, kita ada boy 1, 2, 3, 4, 5. So what happened here? We can rearrange between these 5 boys. So we have 5p, 5 times with. Now, the remaining girls can be seated, can be arranged between this boy. So girl 3, girl number 4. So our arrangement would be 4p, 4. But between the boys and girl, kita tak boleh terbalikkan. I cannot start with girl. Sebab kalau kita nak start dengan girl, girl, boy, nanti tak cukup. Kita akan terletak boy dengan boy. Sebab boy lagi ramai daripada girl. So kita tak ada cara lain lah. This is the only way. So this can be simplified as 5 factorial times with 4 factorial. So our answer would be 2880. Alright. Settle for example 15. Moving on, example 16. Okay, we have 4-digit number to be formed. Okay, highlight the word form. That means we have to use permutation process. Okay, highlight ni, form. Okay, from the digit 0, 1, 2, 3, 4, 5, and 6. Now all together we have 7 option. That's our option without repetition. So means each number can only be used once. Setiap nombor kita boleh guna sekali je. How many number can be formed if each number for the first condition less than 5,000? Okay, terlupa tadi highlight. Yang mula-mula tu kita nak, salah pen, kejap. Yang pertama tu dia nak 4-digit number. Maksudnya R in this case is 4. Okay, kita kena mula jawab soalan ni bersyarat. Kita mula dengan situation pertama tadi. Less than 5,000. Okay, saya buat kotak. Okay, if our number must be less than 5,000, kotak yang ada syarat penentu, the main criteria to ensure our digit is less than 5,000 would be the first digit number. So, how many options do we have there? We can use either number 1, 2, 3 or 4. Right, I cannot use number 5 because kalau kita guna nombor 5, for sure dia akan lebih daripada 5,000, and number 6 pun akan lebih. 0, I didn't choose here because we must use 4-digit number. Kalau kita letak 0, maksudnya nombor tu akan boleh bermula dengan 0. Kalau mula dengan 0, dia dah jadi 3-digit number, not 4-digit number. So kita exclude 0, 5 and 6. That's why we only have 4 option here. 1, 2, 3 and 4. And then the remaining 3 box kita tak ada syarat kan, because the condition is less than 5,000 only. Okay, now we may start with the arrangement. So from the first box itself, out of 4 option, I only want to use one number there. So 4p1. Okay, times with, now how many option do we have left? Okay, all together, remember just now we have 7 option. Saya bulatkan tu, and is 7. One number I already used on the first box, on the first space. Means now we left with 6 option. Ada 6 lagi nombor kita belum pakai. So out of 6 option, how many empty space do we have left? Kita akan ada lagi 3 tempat yang kita boleh susun. So 6p3. 4P1 times with 6P3, our answer should be 480. Okay, kita pergi situation yang kedua. Now, begin with digit 4 or 6. Okay, still 4 digit number. Saya buat 4 kotak. Now, syarat dah berubah. We must begin with number 4 or number 6. That is our condition now. So same as before, we start with the box that have a condition. So for that first digit number, for the first space, we can use only 2 options. So 2, we only want to arrange one of them there. Means 2P1. Okay, settle with the first box. Now, how many number left? We have another 6 option that we haven't used. We want to arrange them into these 3 empty space. So 6P3. 2P1 times with 6P3, you're going to get 240. Okay, settle for B. Next one, C. Okay, still 4 digit. Saya buat dulu kotak. Now, our condition is between 2,000 and 6,000. To ensure we have that arrangement, we have to focus on the first digit itself. Itu penentu kita dapat nombor between 2,000 and 6,000. Kan? Okay, so means now we can only either use number 2 or number 3 or number 4 or number 5. Kita boleh guna antara 4 nombor ni je. Okay, 6 saya tak boleh. Sebab kalau kita guna nombor 6, for sure number nanti dah jadi greater than 6,000. Tak dapat lah between 2,000 and 6,000. Okay, so we have 4 option there. So our calculation should be 4P1. 6 number left, we arrange in the remaining 3 box. So 6P3. Calculation 4P1 times 6P3, answer is 480. Calculation dia macam sama dengan A kan, tapi situation dia berbeza kat situ. Kebetulan number arrangement dia sama. Okay, alright, move on to the last case. Our arrangement must be an odd number. Okay, saya buat kotak dulu. We must have 4 digit, but now situation is it must be an odd number. Okay, remember the condition. In order to ensure we have an odd number, means last digit must also be an odd. Kalau kita nak susun nombor yang ganjil, odd number, nombor terakhir mesti nombor ganjil juga. Sama je kalau we have to ensure an even number, last digit must be an even number. Okay, so now focus our condition on the last box lah. Box pertama tak ada syarat. Kita tak kisah. Depan tu genap ke ganjil ke, kita still akan dapat ganjil kalau kotak terakhir tu nombor ganjil. Alright, so from our option, how many odd number do we have? We can use either number 1 or number 3 or number 5. Okay, okay, itu condition for the last digit. But remember, condition for the first digit, we must have 4 digit number. Means for the first digit, our option would be we can use either number 1, 2, 3, 4, 5 or 6. Exclude 0 from our first digit. Kan kalau kita ada kosong kat depan, nanti tak jadi 4 digit, dia dah jadi 3 digit. Tadi kita dah ada cerita benda tu. Means in this situation, we have 2 different box that have a condition. 2 tempat tu kita ada condition. Okay, so since our situation is without repetition, setiap nombor tu kita boleh guna sekali sahaja. Make sure each box tak ada nombor yang overlap. Okay, kalau tak nanti arrangement kita akan jadi berterabur. Sebab nombor tu kita tak pasti kita dah guna ke kita belum guna. Okay, so now we have a problem here. Kenapa? Sebab ada nombor yang overlap. 1, 3 dengan 5. Kita boleh pakai kat kotak pertama, kita boleh pakai kat kotak terakhir. Dua-dua tempat kita boleh pakai. So kita tak tahu nanti kita dah pakai ke kita belum pakai. Okay, sebab kita boleh guna nombor tu sekali. So if this happen, so we have to consider each cases. Kita kena pecahkan case tu. Okay, apa maksud pecah? Saya kena pecahkan case last ni lah. Kita ada 3 different number there, 1, 3 and 5. So saya kena pecah kepada 3 different case. Okay, saya buat teruslah. I kena ada 3 different case here. Okay. So kita consider first case dulu. If our N is 1, last digit is 1. Okay, so kalau kita dah very sure our last digit is 1, means for the first digit, we cannot use number 1. So we have either number 2, 3, 4, 5 or 6. Nombor 1 je kita tak boleh pakai. Alright, so now our arrangement would be 5P1. Because for the first box, we have 5 options. We only want to arrange one number there. So 5P1. Okay. Times with, consider the last space. We will use number 1 there. So 1P1. Kenapa? Kita ada satu je pilihan nombor 1. Nak susun kat kotak tu. 1P1. Okay. And then remaining, we would left with another 5 option. Tadi altogether, saya tulis balik kalau tak terlupa dah. Altogether, we have 7 option, right? So, first number, kita dah guna kat first box. Second number, kita dah guna kat last box. So, now we have remaining 5 option. We want to arrange in this remaining 2 space. So, 5P2. 5P1 untuk kotak pertama, 1P1 untuk kotak terakhir, 5P2 for the remaining 2 space. Okay, so here our answer would be 100. Okay, that's for the first case. What happen if we will arrange number 3 as our last digit? Means on the first digit, for the first space, we can either use number 1 or 2 or 4 or 5 or 6. Nombor 3 je kita pakai, kan? So, our calculation would still be the same. 5P1 for the first space. And then 1P1 for the last space. After that, we have 5P2 for the remaining 2 space. So, this will be also equal to 100. And then for our last case, we can use number 5. So, for the first box, it's either number 1 or 2, 3, 4 or 6. So, we have 5P1. 5 option for the first box, for the first space, and then 1P1 for the last space, and then 5P2 for the remaining 2 space. So it's still 100 here. Okay, coincidentally we have same number of option for each cases, but then for each tu sebenarnya case kita lain-lain kan, nombor ending kita berbeza, pilihan untuk kotak pertama pun berbeza. Kebetulan bilangan pilihan tu sama banyak. Okay, so this is our arrangement. Since we have 3 different cases, to find the total way of arrangement, you have to sum this up, add all of this. So our final answer should be 300. Kena tambahkan setiap satu case lah, sebab kita ada 3 case yang berbeza. Alright, that's for arrangement for odd number. Dia jadi banyak sikit jalan kerja kita. Okay, saya kecilkan. Alright. So, ini summary dia. Nampak berbeza kan? Sebab semua situation, semua condition berbeza. Okay. For question A, B and C, kita tak ada pecah case because condition only lies on one space. Syarat ada kat kotak satu tempat je. Kotak pertama tu yang ada syarat. Tapi for case D, ada 2 tempat yang akan disyarat. Sebab tadi apa? Kita nak make sure dia 4 digit. So, kotak pertama tak boleh guna nombor 0. Kita nak make sure it's an odd number. So, kotak terakhir pun ada syarat. And then, dia jadi masalah because ada number yang overlap. That's why we have to split into 3 different cases. Okay. Kita cuba lagi another example involving arrangement of number. Favorite question lah, arrangement number ni. Okay. So, how many 4-digit even number, terus ada syarat tu. 4-digit even number can be formed automatic, this is permutation, from 0 up to 7 to make up between 2000 and 6000. Okay. Kita ada 3 different condition here. So, and then our N is 8. From 0 up to 7, we have 8 different option. And then our R is 4 in this case because it's 4 digit. And then we have 2 different condition. It must be even number. And then it must be between 2000 up to 6000. Alright. And then we have to consider different cases now. For the first one, part A, without repetition, means on each number we can only use once. Okay, kita mula seperti biasa, kita buat dulu kotak. How many box do we have? We have 4 different box because we only have to arrange 4 digit number. Okay, so now remember the first condition. What is the first condition? It must be even number. So to ensure that our last digit also must be an even number. Kalau kita nak susun nombor yang genap, kotak terakhir pun mesti nombor yang genap. So how many option do we have? We can use either number 0, number 2, number 4 or number 6. Okay. And then to ensure this is between 2000 and 6000 means we can either use number 2, 3, 4 or 5. Okay, itu syarat je. So this is the condition. Now let's check, because this is without repetition, let's check whether we have an overlap situation. Ada situation overlap kat sini kan? For number 2 and number 4. Okay, means we have to split up the case. Okay, kita akan ada 3 different case. Kenapa? Kita mula dengan case pertama where our ending can be either 0 or 6. 0 or 6 ni dia tak ada overlap dengan syarat yang pertama. So saya himpunkan dia as a one case. So if we use 0 or 6 as our ending, means for our beginning can be either 2 up to 5. Dia boleh 2, 3, 4, 5, tak kisah. Okay, so what happened to the calculation? For the first space, we have 4P1, 4 option arranged in the first box, times with, remember, go to the last space. So we have 2 different options that can be arranged on that last space. So 2P1 times with, alright. So yang ni hati-hati, ingat, all together just now we have 8 different options. 2 number we already used for the first 2 arrangement. Now we left with another 6 option. Kita ada lagi 6 pilihan, 6 option that we will use for remaining 2 space. So 6P2. 4P1 times 2P1 times 6P2. Our answer here should be 240. Okay. Now let's go to the second case if our ending is 0. Sorry, not 0. 0 kita dah buat tadi. Is 2. Okay. If we use 2 on the last space, means for the first space, it can be either number 3, 4 or 5. So calculation should be 3P1 times 1P1 times 6P2. Okay, harap awak nampak dah. 3P1 for the first box out of 3 options arranged on the first space. And then we only have 1 option for number 2. So that's why 1P1. Now we left with another 6 number to arrange another 2 space. So 6P2. Okay, this would be equal to 90. Okay. Next one. If our last digit is 4. So for the first digit, it can be either number 2, number 3, or number 5. So we have 3 options for the first space, 3P1. Only 1 option for the last digit, 1P1. Remaining 6 options for remaining 2 space, so 6P2. To find the total way, you have to sum this up. So our final answer should be 420. Okay. Dia tedious sikit, awak kena hati-hati, but then konsep dia senang, calculation dia senang, dia tak sini. Awak kena careful with the condition. Alright, that's for the first situation without repetition. Okay, now part B, with repetition. What happened for with repetition case? Means each number can be used repeatedly. Maksudnya setiap nombor kita boleh guna banyak-banyak kali. Okay, our condition is still hold 4 digit. To ensure it's even, tadi kita ada syarat kat last space. We have 4 option. For the first space, kita ada 4 option juga. Okay, since each number can use more than once, for this one, kita tak payah split up the case. Kita boleh kira one go je. Tapi, kita kena consider digit by digit. Kotak by kotak, kita kena consider the situation. Okay, so kita start terus dengan the first case. Okay, for the first space, we only have 4 options there. So, 4P1. Okay, moving on to the second space, here we have 8 option. Tak payah tolak kan? Sebab setiap nombor boleh pakai banyak kali. So, untuk kotak yang kedua, space yang kedua, no condition at all. So, altogether, we have 8 different option we can arrange on this space. So, 8P1. Same thing for the third space, it's still 8P1 because we still have 8 different options. And then times with, for our last digit, last space, we only have 4 options there. So times with 4P1. Here, our answer would be 1024. Okay, but that is not the final answer yet. We have to minus with one case. And then final answer will be 123 way. 1023 different arrangement. Okay, now why we have to minus with this one case? Right, remember back the condition, our number must be between 2000 up to 6000. Means di antara 2000 sampai 6000. 2000 is excluded. 2000 tu tak termasuk. So, we have to consider this situation. Let's say, what happen if, okay, number first tu, saya terpilih nombor 2. Boleh kan? Sebab kita ada option 2, 3, 4 and 5. So, kita terpilih arrangement untuk number 2. Untuk kotak yang kedua, ada 8 option. So, saya boleh pilih number 0. Kotak yang ketiga pun sama, saya boleh pilih 0 sebab nombor boleh pakai banyak kali. Kotak yang keempat pun saya terpilih nombor 0. So, 2000 might happen. Possible berlaku, kita susun-susun, kita jumpa nombor 2000. But then, we have to exclude that part. Sebab tu, kita kena tolak satu case. A case 2000 happen. That's why final answer would be 1023. Okay. 6000 won't happen sebab 6000 takkan terjadi sebab our first box kita tak include pun nombor 6. So 6000 tu tak risaulah, takkan terjadi. Tapi 2000, 2000 mungkin terjadi. That's why we have to exclude that situation. Sebab tu kena tolak satu case. Okay. Alright. So saya summarize balik. So this is our calculation for condition permutation involving digit, involving number. Okay, carefully read the question, the condition without repetition or with repetition. If without repetition means you have to consider case by case. Kena letak dulu kat mana yang ada syarat. Make sure yang bersyarat tu tak boleh overlap. If ada syarat overlap, that's why you have to split up the case. Macam kita pecah tadi yang kat part A. Alright. If with repetition means every single digit can be used repeatedly, kita tak perlu pecahkan case. We just straight away consider digit by digit. Setiap kotak tu kita consider syarat. Tak payah asingkan case. Okay. So that's for condition digit. Kita cuba last one for this video. Okay. We have to arrange 3 married couple. Okay. We have 3 married couple means we would have 3 husband, 3 wife. Right. That's why they bought 6 different seats in the same row for a concert. In how many different ways can they be seated? They didn't mention about arrangement at all, but they mention about the seat. So seat tu penting kan? Nombor seat. Kalau awak beli tiket wayang pun, tempat duduk awak tu penting. So arrangement is important here. Okay. First case, without restriction. With no restriction at all means our calculation straight away out of 6 people, we will arrange 6 of them. So calculation straight away will be 6p6 or it can be 6 factorial. In this case, our answer would be 720. Okay. B, second situation, if each couple is to sit together. Imagine macam kita ada couple seat lah kat dalam wayang tu. Okay, kita ada seat number 1 yang macam ni, the side by side. Let's say saya labelkan lah husband 1, wife 1. Okay, and then kita pergi pula couple seat number 2 untuk second couple. Macam tu. Saya pergi pula ke seat yang ketiga untuk the third couple. Okay. Kita sekarang, if they must be sit together, kita assume dia ikat sebagai satu. Okay, saya buat 3 kotak here. Alright, so now how can we arrange them? So first we consider the couple itself first. Okay, let's go to for the first couple. So between husband 1 and wife 1, they didn't mention siapa yang mesti duduk kiri, siapa yang mesti duduk kanan. We can rearrange them, kan? Only 2 of them. Maksudnya saya boleh susun 2P2. Itu untuk couple number 1. Okay, the same thing will happen with couple number 2. We can rearrange the seat between 2 of them. So, times 4, 2P2. And then, once again, benda yang sama lah berlaku untuk couple yang ketiga. So, times with another 2P2. Okay. So, that's for the between the couple itself. And then, we have to consider this group. Why? Because they didn't mention siapa nak duduk tengah, couple mana nak duduk kiri, couple mana nak duduk kanan. Means I can rearrange between the couples. How many group do we have? We have 3 different group. So we have to times with 3P3. 3 kumpulan ni kita nak susun. Or you can simplify this as 2 factorial times 2 factorial times 2 factorial times with 3 factorial. Okay, benda yang berbeza kat situ Ingat, 2 factorial yang pertama untuk couple number 1. Yang kedua untuk couple number 2. Yang ketiga untuk couple number 3. Itu kita consider each couple first between husband and wife itself. And then 3 factorial is we consider arrangement between these 3 couple. Kita susun kumpulan dia. Alright, so our answer in this case would be 2 to the power of 3 times 3 factorial. So our answer should be 48.